Hi everyone, and welcome to our next tutorial. In this tutorial we're going to take a look at how we implement voltmeters and ammeters in circuits. So we have this circuit here and it looks fairly complex, and that's simply because of the way we draw ammeters and voltmeters in circuits. So here we have our DC power source here, and we've got an ammeter here. So really what would happen is when this circuit is connected, current would flow this direction if we follow conventional current flow, and then it would travel down here. And then from here it would see that this is a parallel circuit. So what will happen is some of the current will travel this direction, and some of the current will travel down this direction here. Now notice here that this battery source is being monitored with this voltmeter. We're measuring the potential difference from this point here to this point here, and the voltmeter is reading this as 6 volts. So what that means is, in a parallel circuit, if the DC voltage is 6 volts, the voltage drop across each branch is going to be equal to that value. So I know that the voltage drop across this resistor here must be 6 volts, and the voltage drop across this branch must be 6 volts as well. What about the current? Well, if we make the assumption here that the two resistor values are the same, what that means is the battery looks out to the circuit and says the resistance down this branch is the same as the resistance down this branch. Therefore, equal amounts of current are going to go down each branch. So coming out of the battery, if this is measuring 2 amps, coming down this branch here, this must be 1 amp, and this right here must also be 1 amp. What happens is 1 amp travels through this branch and goes to here. 1 amp goes this way. When they get to this point here, they add together and add up to 2 amps. So 2 amps is going to flow back into the battery, go through here, and 2 amps will come out. This is what we call Kirchhoffs current law. In a parallel circuit, the total amount of current leaving the battery must equal the total amount of the current coming back into the battery. 2 amps is leaving the circuit, leaving the battery, and 2 amps is returning back into the battery. So that's how we label voltmeters in a circuit, how we label ammeters in a circuit, and how we use Kirchhoffs current law in a parallel circuit. That's it for this one. Take care. We'll talk to you soon.